We follow a planet that is not failing gently, but shifting fast. Record heat, ocean change, and a climate engine that is wobbling under the pressure of our emissions. The most important fact is simple and brutal. The planet is getting hotter, and the years are stacking up like a fever chart. Scientific authorities confirm that 2024 was the warmest year on record, and global averages briefly crossed the 1.5 degrees Celsius threshold that governments considered a guardrail. That's not a slogan, it's a measured global average temperature compiled from satellites, ships, weather stations, and buoys. The practical meaning, the climate system is now entering temperature territory that humankind has never managed. That warming shows up in everyday violence. 2/3 of Earth's surface recorded unprecedented monthly heat during 2024. Lands and seas scorched by records that once came once in a century, now arriving in clusters. Cities baked, crops failed in zones unaccustomed to drought, and heat records stacked in regions from the Arctic to the tropics. Those are not isolated impacts. They are a new baseline for what weather can be. The oceans are absorbing the heat and paying the price. If the atmosphere is the fever, the oceans are the heat sink, and they are taking the damage. In 2025, the oceans reached unprecedented warmth, storing zettajoules of excess energy and amplifying storms, bleaching reefs, and swelling the global sea level. Warm water expands, and that thermal expansion is already pushing coastlines inward. The oceans are not just warmer at the surface, the heat penetrates deeper, changing stratification and oxygen levels in places that once felt stable. This ocean warming accelerates two critical processes: stronger storms, because hurricanes feed on ocean heat, and sea level rise, because warm water occupies more volume and because ice on land is melting and pouring fresh water into the oceans. That's a simple chain. Heat in, more energy for storms, more extreme weather on land. Heat in, thermal expansion plus ice melt, more coastal flooding. The data we have now shows both links are already in motion. Sea levels are rising faster than expected. Global sea level rise is not a paused problem. NASA's analysis for recent years showed an unexpectedly high rate of sea level rise in 2024, a rate jump that reflects rapid thermal expansion and accelerating ice loss. In plain terms, the ocean is rising faster than many planners anticipated, and that acceleration changes the calculus for cities, farms, and infrastructure the world over. Coastal storms that once produced an occasional nuisance tide will, within decades, become chronic, destructive floods. The AMOC, the ocean's great river, is showing signs of weakening. One of the most consequential and least visible changes is happening in the Atlantic. The Atlantic Meridional Overturning Circulation, AMOC, the system that ferries warm surface water north and cold deep water south, including the Gulf Stream's heat-conveying branch, has shown evidence of long-term weakening. Recent high-resolution oceanographic studies reveal patterns of heat transport divergence in the subpolar Atlantic and the development of a so-called cold spot near Greenland, a fingerprint consistent with reduced northward heat flow. If AMOC slows substantially, the regional climate across Europe could change dramatically, with impacts on storm tracks, rainfall, and even growing seasons. Slowdown mechanics are straightforward to explain, but terrifying in consequence. Massive glacial melt pours low-density fresh water into the North Atlantic surface, which inhibits the sinking of salty, cold water that powers the overturning. Less sinking leads to weaker circulation, leads to redistribution of heat that can cause cooling in parts of the northern Atlantic and rapid warming elsewhere. Paleoclimate records show that abrupt changes in the ocean conveyor have triggered major climate shifts before. The difference now is speed. Human-driven melt can push thresholds faster than ecosystems and societies can adapt. Extremes, heat, fire, floods, the new normal. Extreme heat in 2024 and 2025 has not been theoretical. It has been lethal and costly. Entire regions saw records shattered. Heat waves and prolonged high nighttime temperatures killed vulnerable people, stressed power grids, and ignited megafires. Insurance losses spiked in countries like Canada after a cascade of climate-related disasters, fires, hail, and storms that together marked the growing economic toll of a changing climate. At the same time, heavy rainfall episodes, sometimes described as thousand-year storms, flooded cities in Europe and Asia, with fatalities and infrastructure damage that will echo for years. The physics is unambiguous. A warmer atmosphere holds more moisture, and warmer oceans energize storms. That raises two interlocking threats: slow onset changes, sea level rise, glacier retreat, and rapid onset catastrophes, flash floods, intense cyclones. Cities like Miami, New York, and many coastal megacities face both at once: higher baseline water levels plus stronger storms. Geoengineering ideas are emerging, and they're controversial. The scale of change has pushed some researchers to propose radical interventions. One of the most talked about ideas is building submerged curtains or barriers in strategic places around Antarctica to block warm ocean currents from melting vulnerable glacier fronts. Estimates for regional curtain systems run into the tens of billions. Some workshop estimates range in the tens of billions of dollars for short stretches. Proposals like these spark fierce debate. They could slow local ice loss, but they carry huge ecological, logistical, and geopolitical risks, and they do not replace the need to cut emissions. The idea is a sign of desperation, as parts of the planet speed toward thresholds. Humanity is tempted to engineer quick fixes that trade one risk for another. Lunar cycles and the 2030s, tidal amplification of floods. A less obvious risk multiplies our coastal vulnerability, astronomical cycles. NASA's analyses point to a mid-2030s window when a natural combination of lunar cycles will amplify high tides, adding to the baseline sea level rise driven by thermal expansion and ice melt. In plain terms, the moon's natural wobble will align with rising seas to produce more frequent and more severe nuisance and high tide floods, especially in low-lying U.S. coasts and many global harbors. This hydrodynamic overlay means that some 2030s high tides will already reach levels that today's emergency services regard as extreme. Plan for earlier impacts in coastal cities like Miami, New York, and many low-lying deltas. Volcanic winters, food shocks, and the fragility of society. Volcanoes can disrupt climate rapidly. A large eruption that injects sulfur into the stratosphere can cause global cooling for several years. A volcanic winter. History shows such events can collapse harvests and spark social turmoil. In a world already stressed by climate extremes and fragile supply chains, a major eruption could produce cascading effects. Crop failures, forced migrations, and geopolitical tensions. We must prepare infrastructure and food systems for tail risk events, the low probability but high impact shocks that compound climate stress. This is not to say volcanic winter is imminent. Rather, it is a risk multiplier that history warns us to consider. We can still alter the course ahead, but the window is narrowing. The paleoclimate record shows us both the planet's capability for extreme shifts and the lasting consequences when thresholds are crossed. Modern observations, record heat, accelerating sea level rise, a weakening AMOC fingerprint, and looming tidal amplifications show those thresholds are within sight. This is a planetary-scale emergency that requires planetary-scale responses, emissions cuts at the scale of decades, massive investments in adaptation and equity, and international cooperation to manage risks fairly. The climate is not a distant problem for our children alone. It is today's infrastructure challenge, today's migration driver, and today's security issue. If you want clear, science-led breakdowns of the planet's biggest risks and pragmatic, evidence-based ideas for what can be done, subscribe to Discovering the Unknown.